Electric fields are the second of the big ideas. So remember, forces, fields, potentials. Forces describe just the force between two particles. That's described by Coulomb's law. Fields are going to be a force per unit charge. So two charged particles experience a force. If you remove one of the charges, the force no longer exists. Remember how many charges you have to have in order to have an electric force? You have to have two charges. That was true for other things too, like gravitational forces. You have to have two masses. In order to have a contact force, you have to have two surfaces contacting one another. So that's always been true, and it's true for charges too. So if I take away one of the charges, the force no longer exists, but something is there. And we use the electric field to describe this something. It's not a substance. It's not any type of material. It's not even a force. But I know that if I have a single charge there and I bring another charge close to it, then that charge will then experience a force. And we use the electric field to describe the tendency for that second charge to feel that force. Okay, so the electric field is a measure of force per unit charge, F over Q. E is defined as F over Q. Here, I have these two charges. If I have this one, let's say that this one is positive, and let's say that this one is also positive. Excuse me, let me erase this. I'm sorry. I have these two charges. They're both positive charges. They're going to feel, this charge is going to feel a repulsive force. This charge will also feel a repulsive force. And so the way we describe the electric field around this is the direction that the charge would feel. So due to this charge, I'm going to have an electric field that is in this direction. That's the same as the direction as this positive charge. Likewise, if I put a positive charge up here, it would feel a force in this direction. So my electric field will be outwardly emanating from this particle. If we place a charge at a point where there is an electric field, it will feel a force. And that force will be equal to Q times E. We just get that from this definition. I just solve it for F. So imagine if I place a positive Q here, it is going to feel a force, and that force will be up and in that direction. And the value of that force will be equal to the charge that I place right here times the electric field that it experiences at that point. The direction of the field is given by the direction, or excuse me, I'm sorry, not the direction of the field, the direction of the force is given by the direction that a positive particle would feel a force. Let's imagine that I have a negative charge. So if I have a negative charge Q, and I want to draw the field for that charge, you can probably guess what is going to be the direction of the electric field for this negative charge. Is it emanating outward or emanating inward? Or will the lines go out and away from this negative charge, the electric field lines, or will they come in and towards the negative electric charge? We're going to imagine a positive test charge. That's going to be this Q naught. Don't worry so much about the naught. It just really means that it's an imaginary charge and that we're going to use it to test and figure out where the electric field is. So I'm going to take my positive test charge and put it right here. And I'm going to ask myself, what is the direction of the force that this positive test charge feels? And it feels a force that is in that direction. And so that tells me that the electric field is also in that direction. That's what we did before, but here we're really formalizing this idea that we have a positive test charge, this imaginary charge that all I do is I use it to help me describe what is the electric field and where is it pointing. I have a couple questions for you. We're going to a couple more things about this. We're going to see electric fields again as it relates to the cell. We'll see potential as well in Coulomb's law. We'll see all of that. We can combine Coulomb's law. Actually, let's pause there.